Geniuses. 3-8. Still graphing a little bit. And now we're dealing specifically with parallel and perpendicular lines when we're graphing them out. Talking about the slopes for parallel lines, also perpendicular lines, not to be confused with the two. In addition, given the equation of a line and a point not on the line, write an equation of the line parallel, but also how it could be perpendicular. A few things to recall about parallel lines are as follows. Two non-vertical lines are parallel if and only if their slopes are equal. I might use this notation every now and again, saying that the slopes are equal for two different lines, using the subscript of 1 and 2 to talk about two different lines. In addition, any two vertical lines are parallel. Well, what other lines could we be talking about here? Not quite vertical, more so from left to right. What kind of line is that? Horizontal. So think this out. If we have two horizontal lines going from left to right, here to here, you can put this, I don't know, wherever you want. What's up with these lines? They're also parallel. Not quite 11, but they're parallel. Yeah, recall that symbol. Let's take this further. Example 1, determine whether the lines 2x plus y equals 6 and y equals 2x plus 1 are parallel, and explain why. Well, this first one already hands us the slope of 2, so we know that this slope is 2. But what about the slope for this? It's in standard form. How can we get the slope of this? Solve for y. Move 2x over. So this is saying y equals negative 2x plus 6. What do you think? Is parallel? Nope. Since the slopes are not equal, these are not parallel. If you're not convinced, you could try to graph these out. But in the previous section, you learned how to graph these, so graph them out yourself if you're not convinced. Next one, a little bit more going on. Write the equation for the line parallel to y equals negative 4x plus 3 that contains the point 1, negative 2 in point slope form. Then convert to slope-intercept form. All right, bet. Sounds great. We know that we're trying to get a line that runs parallel to this. So if negative 4x plus 3 looks like this, what can we take away from this equation that we can use in here? Well, recall that the lines have to be equal, so we can say that for this new line, the slope is also going to have to be negative 4. All right, well now what? We have a point, we can plug that in here. We also have the slope, we can plug that in here. So let's do that. So we have y, and we're deducting negative 2. This is equal to negative 4, parentheses x minus 1. All right, cool. So we have that point slope form done. We'll clean this up a little bit. Y minus negative 2, we can rewrite as y plus 2. And to go to slope-intercept form, we know this is going to be y equals some slope, and then x, and then the y-intercept. So let's distribute this negative 4. We can get rid of that. And what can we do to solve for y? Get rid of 2. So this is going to be y equals negative 4x plus 2. And how can we check if we're right? Well, I know that this was supposed to run parallel to negative 4x plus 3. They have the same slope, different y-intercept, so that's definitely a safe answer. Great. All right, perpendicular lines. What's different here? We come across perpendicular lines. They're two non-vertical lines, and they're perpendicular if and only if the product of their slopes is negative 1. So opposite reciprocals. What does that look like? One of the slopes might be positive 1/2, and the second slope might be negative 1/2. We know that pump the brakes. Negative 2/1. Yeah, just flip the fraction and make the other one negative. Now we're cooking. So we would be able to say that these are perpendicular. In addition, any horizontal line going from left to right, intersecting with a vertical line, creates 90 degrees, and those are perpendicular as well. Great. So let's see what the perpendicular work holds for us. So we can determine if these two lines are perpendicular or not. Well, they're in standard form, which is a little tricky. If you're really quick with graphing these, go for it, but I'll switch these back to slope-to-intercept form. So I know that this would be 3y equals negative 4x plus 6. We can then say this is y equals negative 4/3 x plus 2. Let's switch this back around. This is going to be 4y equals negative 3x plus 12. Divide by 4 all over that. Y equals negative 3/4 x plus 3. All right, well, what do you think? This had a slope of negative 4/3. This was a slope of negative 3/4. Are they perpendicular? Nope. Because if you multiply those two slopes, it does not equal negative 1. So in that case, these are not perpendicular. All right, let's keep going. Similar to the second example? We're now writing an equation for the line that runs perpendicular to 3x plus y equals negative 5, containing the point negative 3,7, going from there. All right, so we'll do point slope form and then go to slope intercept form. Well, I know that this is in standard form, so let's rewrite that. So this is y equals negative 3x minus 5. The line that's going to run perpendicular to this, well, let's think. This slope's negative 3, and if we multiply it with that second slope, it has to equal negative 1. So what's this slope going to be if it runs perpendicular? If we divide both sides by negative 3, our new slope is going to have to be 1/3. Cool, so let's take this into point slope form. We'll take y minus y1, which is 7. This equals 1/3 x minus x1, which is negative 3. Let's clean this up a bit. 1/3 x plus 1, because remember, subtracting negative 3 gets you positive 3. 3 times 1/3 is 1. 7 is still over here. Let's add that 7 over. So the slope-intercept form is going to be y equals 1/3 x plus 8. And we're done. If we were not sure these would work, we could always fall back on the idea that the slopes have to multiply to negative 1 to be perpendicular, but do not get this confused with parallel lines, in which case the slopes have to be equal. Thanks for watching. If you have any questions, bring them to class.